key, you make another string of zeros and ones. Same thing when you hit the blank. When you move the mouse and click, all this is recorded as zeros and ones. So we have the concept that all the information we have in the world, everything about you, everything about me, history, mathematics, can all be written down as a string of zeros and ones. And then we want to change that information in some way. We might want to search information. We might want to reorder the information. We might want to calculate whether a bridge is going to stand up if it's made up of a particular kind of material. And so the computer has two aspects. One is it stores information as zeros and ones, and it changes the zeros and ones to a different string of zeros and ones. So that's the basic idea of computers. And as we know, computers are very powerful, and they can calculate many things, but there still exist some problems that are very hard for computers. Let me give you an example. If you buy something on the internet and you use a credit card to make a purchase, you type your secret credit card details into your computer and send it over the internet. Why can't somebody steal that information? Why do you think that that information is safe? It's not because the information's not being tapped. Somebody out there can read everything you send. So what you do is encrypt it. The information about your credit card is not plain. It's manipulated with other zeros and ones, so somebody intercepting can't tell what the information is. The idea that I'm interested in is not to build computers that are made of zeros and ones and made of the Boolean logic to manipulate the zeros and ones, but instead to make use of one of the great revolutions in the last century, known as quantum mechanics. So the idea is that if you take sunlight and you hold up a prism, it will spread the light into a rainbow of colors, and we see a rainbow. But in the cases of stars and a lot of other sources, we don't see a continuous rainbow. We just see fine lines out of it. So there was that problem. There were other problems at the time. And what these problems told us over 100 years ago is that the laws of physics didn't make sense. And to make a long story short, if we make a computer out of these principles and use interference, we can make some problems that are hard to solve easy to solve. In quantum mechanics, we're allowed to have the 0 and the 1, in a sense, coexist simultaneously. We can consider building computers making use of the laws that govern the weird properties of atoms and of nuclei. And if we build them in that way, then we don't have zeros and ones, but we have all possibilities of zeros and ones simultaneously existing. And when we process it, we can make the processing interfere like waves interfere. So let's consider an electron. You know the electron, if you think of a hydrogen atom, you've got a nucleus at the center, and you've got an electron that orbits it. And the electron has a spin. It can spin up or down. If we call up a 0 and the spin down a 1, so here's the 0 and here's the 1, if we use a magnetic field, we can change the direction of spin. And if we change the direction of spin, we can think of it, if it's like this, we can think of it as having a component of 0 and a component of 1. Quantum computers can have very good benefits. And I'll give you an example. There are super materials that are not seen in everyday life, but are important for some applications. And one example is in hospitals. When they do scans to check whether a person's brain is working okay, they use something called a superconducting quantum interference device that is very sensitive to magnetic fields, and it's using superconductors. We think that there are many other supermaterials with many other benefits out there. The problem is that in order to discover these or to model them, we can either get there by accident using experiments, or we could have our theories test our theories. But the theories are not easy to test on computers as we know them today. So a quantum computer could allow us to test models for new supermaterials with applications as or more important than scanning the brain.